Okay, this time we have a very nice problem which has got a circuit diagram as shown here. Now this has got quite a few elements. Okay, so bear with me as I complete drawing this diagram. It's got quite a few elements. These devices have a generic name element, and we are looking at various rectangles, which is usually a load. We also have a circle, which usually is a source providing electricity. And sometimes we see some weird shaped uh, figure. And the intention here is to suggest that regardless of what this shape is, it is an element, meaning electricity is flowing through it. As you would notice, this point or the node, as we call it, number 1, so it's a 2, and this one is 3. They're called the nodes. This one here is 4, okay, and this one is 5, this node, this one, and this one here at the bottom is 0. That's the commonly called as reference node. Do not worry for now why we call it reference node. That will come later on. The current that's flowing here is I sub 1. That's the name. And this way, on this side, we have I sub 2 flowing. And we have I sub 3 flowing in this direction. That's I sub 3. And I sub 4 and I sub 5 are flowing here. Along this direction, I sub 4 is flowing, and I sub 5 is flowing along this direction. Quite a few directions, if you will, but that's okay. So our goal here is, given the info, such as I sub 1 is given to be 2 amp. These are given set of information. I sub 1 is 2 amp. Writing here on this tablet is kind of tricky, so bear with me on this. I sub 2 is 8 amp. And I sub 3 is 5 amp. We have to determine quite a few currents, such as what is I sub 4, what is I sub 5, what is I sub 1 to 2, I sub 2 1, I sub 3 2, I sub 2 4, and I 0 5. We will get all of them using what we call the Kirchhoff's current law, KCL, given by Gustav Robert Kirchhoff. Now, if we go to node number 1, what we say is I sub 1, I'm going to write KCL at node 1. So that implies I sub 1 is coming to the node, so minus I1 using passive sign convention, plus I1 to 2. So we would write the double subscript 1, 2, meaning the current is starting at the node 1 and going towards node 2 equals 0. Notice that I1 is given to be 2 amp. So if minus I1 plus I12 is 0, then we're saying I12 is equal to, I'm right here, I12 is equal to, what have you now, is the same as I sub 1, and which is 2 amp. So that's determined. It's one of the questions. The next thing that's being asked is what is I21? But first let me put a rectangle around this to highlight the answer. So the next question is what is I21? And I21 is the reverse or opposite of I12. Since we know what is I12, I21 is determined as well. So that will be minus 2 amp. Okay? Let's put another rectangle here. It's kind of a little tricky to draw on this tablet. But anyhow, we saw it. The next problem is about I32, which is uh, from node number 3 to node number 2. Now, we can use the KCL at the node number 3. So again, Kirchhoff's law at the node 3 will give us, using passive sign convention, I32, so that's leaving the node number 3, I32 has to be plus, and I2 is also plus. So I32 plus I2 equals 0. Now, what is I2? I2 is given as 8 and. Therefore, this expression implies I32, which we have to determine, is found as minus I2. And as we say, I2 is 8 amps, so that's going to be minus 8 amp, okay? So that's determined. We might put a box around this thing to highlight our answer, so that's a done deal. Next, we have to determine I24. So it has to do with the node number 2. Notice node 2 has 3 branches. The one on the left, but first let's write KCL at node number 2. So this has got 3 branches, like I said. And if we said current is coming from node number 1 to node number 2, that current is entering the node. So passive sign convention says it's a minus. So what have we here is minus I12, and then if we say current is leaving the node 2 going towards 4, that's going to be plus, so plus I24. And again, remember, we're using passive sign convention, according to which current entering the node is negative, current leaving the node is positive. You got to remember that. Then if we say 2, 3, that current is starting at 2 going toward 3. So it's leaving the node as well, so plus I23. So notice that unlike other nodes we have considered, this one has 3 lines, 3 branches, 3 wires, and so 3 terms in the current. Now, since we know I12, which is 2 amp, so we can do minus 2 amp with that, plus I24, that's what we wanted to find, plus I24. And what else? Plus I23. Now I23 is also determined because we know I32, I23 is just the opposite of I32, so opposite of minus 8 is plus 8. Alrighty? So that will give us equals 0. So I24 plus 6 equals 0. Meaning I24 is minus 6 amp. All right, this is minus 6 amp. So that's another answer. We got it. Finally, at KCL at the node, reference node, the way on the bottom, that will be the last node we will consider here. So that will mean we have 3 branches once again. The one going towards node number 1 is leaving the node 0. So I01, that's a positive, of course, plus I05, because that is also leaving the node 0. And then if we look at it, we see the current is coming from 3 to node number 0. So that is coming, so minus I30, which is the same as I2, which is 8 amp. So what have we here is I01 is I sub 1, which is 2 amp. So we have 2 amp, and then plus I05, okay, and minus I30, which is I2, which is 8 amp. So minus 8 equals 0, meaning I05 is 6 amp. So we got all the quantities we have to find. But don't stop it right there. We will have more fun if we go plug these numbers in the circuit and see if they make sense. So let's redraw this circuit. All right. So we have the same circuit redrawn, but this time having the knowledge of all these numbers to see if they make sense or not. That's where the fun is. and hopefully they will make sense, but we have to check this thing. Again, as I said, the most fun thing is when we say filling all the numbers, if they're making sense or not. That's where the fun is. Uh, so hang on with me for a little bit. Well, let's see here. It's a little bit going out of the space here, but you got the idea. So if we go, well, let's see here. At the bottom, it's kind of difficult to see, but we got the idea. Now, I sub 1, what is it now? I sub 1 is 2m. Remember, the one that's coming here is 2m. So 2m is going here. And this is the node number 2. Remember that. And I sub 2 is 8m. So this is 8m. And now, what we know is I24 is minus 6, meaning current is actually coming from 4 to 2 in an amount of 6. So, at this node number 2, what we see is 2 is coming from here, 6 is coming up. So at node number 2, 2 and 6 combines to give you 8. And this fellow 8 is coming down, this line 8 amp continues to flow. Now this 6 amp here is being made of 2 currents. One is coming this way, all right? So how much is that? That's a negative of I5, all right? And which is the same as I sub 3. I sub 3 is going there and then coming up. So I sub 3 happens to be 5. So 5 is coming here, 5n. And I4, all right? I4 is coming this way, minus 1, so it's a 1 amp. And so 5 amp is going here, 1 amp is here, and then up here from the 0, we have the 6 coming. Notice that 2 has to go this way, 8 is coming all in all, so 6 will go up here. That 6 is split 5 amp here, 1 amp here, and combines here to make it 6, and the 2 is flowing in this direction. 2 and 6 adds up to give you 8. So the bottom line is, as we examine these flows, we discovered that everything adds up, a perfect bookkeeping, everything makes sense, and that's when the problem comes together and makes more sense and more, gives us more enjoyment. This is a really satisfying problem. All we need here is the current law given by Gustav Robert Kirchhoff. And this law helps us find all the current in all the branches just the way it is. Well, that's about it for this problem. Hope you enjoyed this. Bye.